Hello and welcome to the Side One YouTube channel. My name is Ray, and in this video, part 3 of SpotMicro, we're going to look at building the central core of the robot. Now, in the original design, it called for an Arduino Mega 2560 on this pre-printed board. This isn't a particularly good print, but it's got 4 embedded nuts, 2 to hold the Arduino, and it was 2 to hold the MPU6050 using M3s, but I found that when using an M3 on this one, it actually damages one component on the MPU6050. This MPU6050 as a result is no good. But I want to use a more powerful processor than the Arduino, so I'm going to use the Raspberry Pi. Now, the Raspberry Pi comes in a few different flavors. The most recent one being the Raspberry Pi 4 with different levels of memory. This is actually a Raspberry Pi 3. I know my robot lab will run on it. Not as well as on a Raspberry Pi 4, but it'll do for a start, and I can always swap it out with the Raspberry Pi 4 later. It's exactly the same footprint and the connections will be exactly the same. To control the servos, all 12 of them, I'll be using the PCA9685, also known as the Adafruit I2C 16 channel servo driver. I've got a new MPU6050 to put in there, so that's ready to go, and I've got an Arduino Nano. Now, the Arduino Nano, you can load in a program called leodemacondo from my robot lab, and that will allow it to work as an I/O device, a high-speed I/O device for the Raspberry Pi. And that's because in the design it calls for a pair of ultrasonic sensors, and I'm not sure, I did query and haven't had an answer, if I can drive the ultrasonic sensor straight off the Raspberry Pi. So I'll run them off the Arduino Nano. Now, this thing needs power, of course, so I've got a pair of lithium-ion 2S batteries. These are 2200 milliamp hour, which should give me plenty of power to run it for a while anyway. These batteries have actually been used before in another project, the Star Wars D0 robot, or DO. Now let's start looking at the prints for this. So we'll start with the base plate. So this is the exact similar size base plate as this one. So it mounts let's say the front and the back. So it's fairly symmetrical, so our Raspberry Pi will mount in there. So let's get that side of it done first, since it's going to be a nice easy part of it. About the same all the way. Okay, so this print, and there's links in the description, has little standoffs built on for screws to go in, and they line up with the screw holes on the Raspberry Pi. Now, these are M2.5s. Okay, so if we designate this the front and this the back, we'll put the PCA9685 at the back, and we'll use the M2.5s again. Okay, The last M2.5 that we'll be using is going to secure the MPU6050. Now when you have a closer look at the MPU6050, you'll see there's a little resistor up this end, or a capacitor, that's very close to our mounting hole, and that's the one I damaged on the other one using an M3, so I'm going to mount it using just the one hole. Now this original plate was designed to have two PCA9685s on it, and it's something that I could consider down the track and relocate where I mount this MPU6050. Now there's a link to in the description for this part as well. This is a Arduino mount. I found it as a completely different project because I wanted some way of mounting this, and this works well. It lets you slide the Arduino in from the side and gives you access to all of the pins. You've got to remember, when you solder the headers in, you've got to head them up so you can access the reset button as well, and that holds in there quite snugly against the headers. And what we're going to do in this case is hold it in by welding it in, and for that I'll need the 3D pen. I accidentally hit the eject button. It's not the first time I've done that. It's a pain when it happens though. A lot of moisture in this filament. I probably should have welded this on before I installed the Raspberry Pi. Or the Arduino for that matter. Alright, that's in there solidly. Now I'm just going to put that to one side and come back to it in a minute, because we've got these. Now these are all held together with the end frames, which are these, with M3 screws, and they have nuts that embed into these holes. But one of the problems I run into is these nuts will fall straight through, and it's hard to get them to stay put. So what I'm going to do is put a nut in each of these for now with a screw, and then we're going to weld those nuts in place with the 3D pen. Now these are an M3 screw, 12mm long. Okay, both of those. Now, there are two of these, they're identical, one's for the front, one's for the back. They do have embedded nuts, both here for the square nuts, and in the bottom here are M5 nuts. They're hex headed nut, or hex nuts in those there and on the other side. So this is the top, this is the bottom. And I have actually got these M5 nuts. To make it easier to install them, sometimes it's easier to put them in. I'll do the top first. and then hold them in place with the screw. Now these screws are used to hold both the top and bottom covers as well as the front and back covers. What we're wanting to do with this glue is just hold the nuts in. It's not structural, we're not actually welding two parts together. We just need to make sure that it's melted into the base plastic and surrounds the nut, so that it can't come out. Now when you're doing this, there's a couple of holes through here and a bit of a slot in there as well. That's for a small cable tie. You don't want to fill that in while you're doing this. Okay, that's all the M5s installed. But that's not all of our screws. We've also got captive nuts go up here and down here on both the front and the back, and they're used to hold the outer mounting plates which support the servos. So let's get those in. So while I'm doing this, I want to get this part ready. So this is one of the battery holders, and the idea is the battery can sit in here with the other one at the other end and be held up underneath the instrument plate. So what we're going to do is install captive nuts in here, and we'll hold those with the screws and weld them into place as well, which will make installing the batteries that much easier. Okay, start our welding again. Okay, that's all the welding done. Okay, so the wide part is the top, narrow part's the bottom. On these parts, you may see this, it's got like a little notch arrangement. That's for the base plate to sit into, so it goes to the bottom. So that mounts like so. Right, before I put that in, let's get part of our battery holder in. Now I'm not going to do these all the way up yet. I want to get the battery in before I do it all the way up. In hindsight, I should have done the other one first. Oh, I got them both in. Well, that's problematic. I mustn't have welded that in from the other side. That's going to make it more entertaining. Let's come back to the other one. Hey, that nut's spinning in there. Alright, I will have to come back to that another time. Alright, so that's the basis of our frame for the main body section. We've got our electronics in there. These covers simply slip over the top once we take these screws out, and the bottom. And gives us a reasonable looking dog. So okay, so just before I finish off this video, I did print out these parts. And these are a stand to hold the robot. Now, while I don't need a stand right this moment for the assembly of this robot, I will do as soon as I put legs on it, which is what I'm planning on doing. So using these nuts and bolts, and again everything will be linked in the description. These are M4 12mm long with hex nuts for joining that part and this part together. So we print off two of these. They join in the middle to give us our height. Could have gotten away with 10mm long, but I didn't have any, so we've got 12s. Okay, so these stand apart and we use this. Now I could plastic weld the nuts in like I did for the body, but we have ready access to this, so I'm not going to bother at this stage. There's no reason why you can't if you wanted to. Again, 12mm long, in this case M3 screws with M3 square nuts. Just make sure you put the U side shapes together rather than the other way. Okay, so to give it a bit more stability, there are these four parts that print with the cross sections. They just push onto the bottom. You could weld or glue them on. You know, if I put them on the right end, it'd help. I was wondering why they weren't sitting on properly. That's better. Now we can sit our base on properly, or sit our robot on this new stand, and there's enough room that the legs are clear of the ground once they're installed. So that'll do for this video. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. Let us know what you think of the videos or ways we can improve it with a comment. It is a form of support that helps the channel a great deal and costs you nothing. If you'd like to help the channel further, I do have a Patreon account. There is a link in the description, and you can join my VIP members, Go Lucky and Lawrence Berger, as well as my other members, Al Morales 45 and Ratchet. I also have a Discord channel with a growing community of avid robot builders like yourself, and they're willing to answer questions, and you might be able to answer some of their questions as well. And we'll see you in the next video.